Hi class, let's take a look at this problem here. We have pairs of numbers, 1, 4, and 10 are the number of households, and we want to basically group these into sample sizes of 2, and we want to count the number of even numbers in each of these sample sizes. So as you can see here, they give me the groupings here: 1, 1, 1, 4, 1, 10, 4, 1, 4, 4, 4, 10, etc. So if I look at this in Excel, okay, for the pair 1, 1, there are 0 even numbers. 1, 4, there's 1 even number. 1, 10, there's 1 even number. 4, 1, there's 1. 4, 4, there's 2. 4, 10, there's 2. 10, 1, there's 1. 10, 4, there's 2 even numbers. 10, 10, there's 2 even numbers. So in terms of the percentage of even numbers, there can either be 0 out of 2, 1 out of 2, or 2 out of 2. So that gives me 0%, 50%, or 100%. And of these proportions, you can see that there's 1 that is 0%, there are 4 that are 50%, and then there are 4 that are 100%. And in decimal form, these are the results, okay? So this becomes the probability distribution right here, okay? So now choose the correct answer below. The proportion of odd numbers in the population is equal to the mean of the sample proportions of the even numbers. The proportion of even numbers in the population is not equal. The proportion of even numbers in the population is equal to the mean of the sample proportions. The proportion of even numbers in the population is equal to the mean of the sample proportion of the odd numbers. Well, according to the definition of an unbiased estimator, of which the proportion is an unbiased estimator, this is going to be the appropriate response. The proportion of the even numbers in the population is equal to the mean of the sample proportions, okay? So if I look at this from a population standpoint, I have 1, 4, and 10. So therefore I have 2 divided by 3. 2 divided by 3. That's going to be the population proportion of even numbers out of the total, okay? And then if I do the proportion of the sample means, I take each of these values and multiply it by its corresponding probability. So let me copy these down here, and then I add these results up right here, and that gives me 0.66667, and that is equal to 2 divided by 3. So indeed, sorry about that. 2 divided by 3. So basically 0.66667, okay, if I take 2 divided by 3, is going to be 0.66667, okay? And let's continue. So choose the correct answer below. The sample proportions do not target the population. Okay, so proportion is an unbiased estimator, okay? And as an unbiased estimator, the proportion of the even numbers in the population is equal to the mean of the sample proportions. And as an unbiased estimator, it will target the population. So we know that it's going to be either C or D. And if you read through these, A and B is not valid because it says do not. C is not valid because it says here the sample proportions do not make good estimators. Therefore, the answer has to be D. Proportion is an unbiased estimator, which means it is going to be a good estimator for the population proportion. Thank you.